we've seen how to set up strings, and there's a couple of different ways, and we treat them as somewhat equivalent, but there are some subtle differences between strings as used as an array of characters as opposed to pointers. So, for example, here is str declared as an array of characters. Of course, we assume that whenever we see something like this, it's probably a string. And we can assign str, that's the value of something in double quotes, a string. So we have a sequence of characters enclosed in double quotes, and this is a sequence of 17 characters. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and we know that there will be an 18th character, which is a null termination. So the way this is supposed to be used, what you're saying is you have an array of characters declared. In this case, it's declared on the stack, and these 17 characters can actually be changed individually. So you can actually go in there into str, say str sub 0 is equal to whatever you want, lowercase t, and you would be converting this to a lowercase t. So you can change individual characters if you use a string this way. Now on the other hand, if you have char star str, remember we said that whenever you see a char star something, chances are good it's not just a pointer, it's actually just a sequence of null terminated characters. So whenever you see a char star str, you might think it's exactly the same as this. Well, actually it isn't. There is a slight difference. And the difference is that when you set up a string like this, this is a string that sort of lives in an area of memory that's reserved for constants, things like that. And so all you're doing is that, all you're saying is you're saying str now points to this area of memory where there are these characters, which is also null terminated. So they're both null terminated, this and this, but the understanding at least is that, or this is what you want to stick to, is that str is a pointer to a string constant. Okay, so this should not be changed. So you should not go in there, although you could, if you say str sub 0 is equal to t, well, actually I'm not sure. You should, you can try it out, see if it works. Even though you might be able to get away with it, it's something that you should not do. Why? For one thing, because this string might be shared by many variables. So if you change it in one place, you might be doing some damage somewhere else. Okay, so there's a subtle difference. If you declare it this way, you're saying, okay, this is a character array or a string that I can change. If you say char star str and assign it the value of that is a pointer to a string, then the understanding at least is that you should not change any of this, any of the individual characters. Okay. So let's do it the former way. So for example, you say char star, the first way that is, you say char str open close square brackets. You're saying this is an array. We're setting the contents of that array essentially, and then so you can say pointer is equal to char star. You can for instance say str is equal to str sub I, starting from 0 all the way to 16. Remember there's 18 characters here. You can set it equal to some number starting from 0 plus I. So this will go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there'll be some other values. So this is all fine. You can do this. You can set individual characters inside this array str. And also you can do this. You can have a pointer point to the same location as str is pointing to. Now, if you dereference pointer, you will be pointing to str sub 0, which is, in this case, we set it equal to 0 plus 0, which is just 0. Pointer plus 1, dereference that. You guys know that you can do pointer arithmetic in C. So what we're doing here is we're saying, look at the next character. So we declared pointer to be a pointer to character, so we know that this is going to be pointing to the very next byte. Okay, pointer plus 1, and then you dereference it. That should be a 1. Pointer plus 2 should give you a 2. So you can use str instead of pointer, but it's not common practice. Setting str equal to pointer is actually not allowed by the compiler, by the C compiler. This is illegal because these are two different types. str is pointer to character. str is an array of characters, and pointer is a pointer to a character. So you can do this. You can say pointer is equal to str, but not str is equal to pointer. That's illegal. You can use array notation with pointers, and you can do the opposite. You can use pointer arithmetic with array, but it's typically not done. Okay. So there's a bunch of things that are sort of odd about C strings. When you pass strings into functions, of course, in Java we're used to knowing about the length of an array, and therefore length of a string too, because strings in Java are just pointers, are just objects. They are objects that actually have a pointer to an array of characters, sort of just like C, but difference is in Java strings have methods like length, and so you can find out how big they are. However, when you pass a string into a function in C, you actually should, every time you pass in a character pointer to a function, you should also pass in the length of that string. So there should be a second parameter over here saying how long the string is. Because while this might be safe, it's probably safe to change the first location in that array of characters. If you say, for example, access the 10th location, that could be unsafe because there might not be that many characters in this string. Okay, so that said, you can actually pass strings into functions as pointers. So all you're doing is passing in a pointer. So remember, some people refer to this as pass by reference, but it's not really. It's just passing pointers by value. Okay, and so the way you would use it would be you call this function with anything, a pointer or an array of characters. Either way, either one will work. Why? Because this declaration char star s is assignment compatible with this declaration str. So you can say s is equal to str. If you had it the other way around, of course, as we saw, it might not work. Okay, so let's say we pass this function pass this pointer or character array, let's say character array str into this function, and it's treated as a pointer to character. If you do something like this, you say to upper s sub 0, that just returns whatever this is. If it's a letter and it's in lowercase, it just converts it to uppercase letter. Here, what we do is we store it back into s sub 0. So we have a pointer to some memory location. We're storing something to the first location in that array. Now, if we pass in str plus 1, we're doing some pointer arithmetic, which we can do. It's allowed. It's not usually done. This would be just like saying, get the address of str square bracket 1. It'll be the same thing. It's not usually done, but this is perfectly legal in C. That is, you get the address of the second thing in this array of characters, pass it to function. What this would do, if in effect, even though we say 0 here, in effect what we're doing is we're setting the second location in this string str to have an uppercase version of itself. Okay, so it's a fine point, but I'm guessing everyone knows how this works. Basically, when you call this function, you're just only going to change the 0th location of this string, this character array. If you pass in str+1, you're changing the h to an uppercase H, effectively. With this third function call, we're going to change this I to an uppercase I. Okay, so it's a fine point, but it's just important to remember that you can do pointer arithmetic here at the calling side. You can do effectively pointer arithmetic. You can, because that's effectively what you're doing here. Okay. So if you want to pass a string into a function but not allow that function to change anything in that string, you want to use const right here in the parameter. So if you do this and you call str, you can be pretty sure that str is not going to be changed, and the C compiler will enforce that. So even no matter what location you're accessing, s0, s1, whatever, it's by making this const, you're saying that you're not going to change whatever s points to. Okay, so you can read the value at s0 into a character and put it out to standard out using put char. So all this would do is print out the t, print out the h, print out the I in this case. So there's a bunch of ways that we can use character arrays. So remember, anytime you see an array, you'll probably see a loop somewhere around the corner. And so if you pass in a pointer to char, that's basically just like an array. And so somewhere in there, you can expect to see a loop. In this case, not always, but since we know that char star means basically a string, an array of characters, you can expect that there might be a loop in a function such as length. So you can write loops like this. You can write a for loop. Takes a little bit of getting used to. What you're doing is this is just a regular for loop. This is the initialization section. You're setting n to 0. We're setting p, a pointer, to point to the same thing that s points to. Alright, and here's the boolean, so it's not obvious this is a boolean function, but remember in C, if this has the value 0, which it will when it hits the null termination, then that means it's false, otherwise it's true. If it's anything other than 0, if whatever p points to, if it's anything other than 0, it's considered true. So of course this does not work in Java. This is not legal at all in Java, but in C and C++ this is legal. Star p, the way it's interpreted is anything that's other than 0 is true. If whatever p points to is null, then that's false and you exit the loop. So this is all perfectly legal. You can do these kinds of things. You can have multiple things initialized within the initialization section. You can have multiple things in the update section of a for loop in Java 2. Usually we don't, just because we want to make things readable. But in C, what you will see is there's a lot of a lot of code written like this. It's not particularly readable. And the one thing that also might be confusing is that the loop body is empty because we end up doing all of the work in here. Here's the Boolean condition. All of the work is here. What we're doing is looking at the next character, updating the count. So in effect, what this short function does is initialize p to s, point to the same thing as s, set the value of the count to 0, bump up the pointer value so that it looks at the next character, checks if it's a null or not. If it's not, keep going, bump up the pointer, at the same time also bump up count, and it keeps counting until it reaches the null termination character. So in effect, what it does is figures out the length of this character. Very efficient, they're also very terse. That is, it's very sort of succinct, let's say. Very hard to read in my perspective, but here's the thing, this is the kind of loop processing that you will see for strings in C code, and we'll look at a few more of these.